Here we are reacting a weak base with a strong acid. The strong acid we're going to represent as H3O+, because that's how it exists in solution. Our initial reaction is that we have the ammonia as the weak base reacting with H3O+ ion to generate NH4+, a conjugate weak acid in solution, plus water. Initially, we have 4 millimoles of ammonia. It reacts in a 1-to-1 ratio with hydroxide ion, so essentially both of these are completely consumed. Essentially, we're at the equivalence point of a titration. In the process, we are producing 4 millimoles of our weak conjugate acid. In water, we don't care about it, it exists as a pure liquid. So we have a weak acid in solution. The relevant equation is that we have our weak acid in solution reacting with water, an equilibrium situation with the weak base plus H3O+ ion. To get a numerical value of the pH, we would first test our approximation as to whether or not 1,000 times Ka is less than our initial concentration. In this situation, we're going to need to convert a Kb value to Ka in our calculation. If our approximation is okay, then we can calculate our hydronium ion concentration as Ka times the initial concentration of our acid. Just be careful that in this calculation you use the Ka value that was obtained from Kb.